Hello everyone! The next topic we'll be covering will be additional transformations, specifically the modulus, reciprocal, and square transformations. Now let's take a look at the modulus transformations, which I feel are the easiest ones. First off, we have fx becomes mod of fx. If you want to transform fx into mod of fx, this means that your fx values will all be positive because you are taking the modulus of fx. How this is reflected in the graph, get it? Reflected, because we're actually going to reflect all the parts below the x-axis over here to be positive above the x-axis. Again, we're reflecting all the points that are below the x-axis to above the x-axis. Take note that the points over here are considered sharp points. They are not smooth curves. So you can't draw this like this. Alright, it has to be like this with a sharp point. The next transformation we need to know is f mod of x. What this means is that we reflect the right side to the left side while just completely negating the left side. So what this looks like is we are reflecting this on the left side while completely negating the left side. So this is the graph of y f mod of x. Again, the point over here is a sharp point. Similarly, for f of negative mod x, this means that we are reflecting the left side to the right side while completely negating the right side of fx. So what this will look like for f negative mod x is we have the left side and then we are reflecting it to the right side. So this is the graph of f negative mod x. To recap once more, for f mod of x, we are reflecting the right hand side to the left hand side. And for f negative mod of x, this means that we're reflecting the left hand side to the right hand side. Hopefully that was simple enough. The next transformation we'll be covering is the reciprocal transformation from fx to 1 over fx. So essentially, what this means is that all the points transform from a, b to a, 1 over b. Two simple rules that we can follow is that when we do this transformation, we first switch the x-intercepts and the vertical asymptotes. The second rule is that we switch any increasing parts of the function to decreasing parts and vice versa. And while doing this, remember that negative y values will stay negative and positive y values also still remain positive. Let's see how this plays out in the first example. So we have the graph of fx here and we want to find the graph of 1 over fx. Let's apply the first rule. We switch the x-intercepts and the vertical asymptotes. So we see an x-intercept here. It becomes a vertical asymptote when we transform to 1 over fx. The next one is we switch increasing and decreasing parts of the function. So look at this part. This is an increasing part of the function. So this becomes decreasing. And actually, for this, there'll be a horizontal asymptote at y equals to 0. Because as fx approaches infinity, 1 over fx will approach 0. And again, let's apply this for the rest of the function. This part over here is increasing, so 1 over fx will be decreasing. This part over here is decreasing, so 1 over fx becomes increasing. This part over here is increasing, so 1 over fx becomes decreasing. And remember your vertical asymptote over here. Moving on to our second example, we have the graph of fx over there. So we have an x-intercept over here, which we'll switch for vertical asymptote. And vertical asymptotes will also become x-intercepts after being transformed to 1 over fx. Before I continue, I want to remind you that all points a, b on fx will become points a, 1 over b for 1 over fx. So this even applies to the horizontal asymptote. The horizontal asymptote will become y equals to half. Let's start actually plotting the graph. We have a decreasing part of the function here, so applying the second rule, this will become increasing. The next part of the function here is decreasing, so what we want to do is switch it to become increasing. And remember, it's still negative because all the parts that are negative will stay negative. And let's draw out the rest. It will actually look like something like this. We'll cross the x-intercept over here. And since this part is decreasing, we'll have it that this part of 1 over fx will increase. And since as x approaches infinity, y approaches 2, for 1 over fx, as x approaches infinity, y will approach half. And finally, after all that, we have the square transformation, which is transforming fx into fx square. First off, if we are squaring a function, the most obvious thing is that all the y values will become positive. So let's say we have fx over here. So if we want to find out what the graph of fx squared looks like, all the parts below the x-axis will be reflected up. So it will look something like this. Note over here that negative 2 squared will actually be 4. So this is not reflected symmetrically. We are taking the square of everything to go upwards. Let me zoom in a bit so it's a bit easier to see. For the rest of the parts, there's one property of squares that we need to consider. When we're squaring a number between 0 and 1, the number actually becomes smaller. For example, half squared will become 1/4. This is when we're squaring a number from 0 to 1. However, if we're squaring a number more than 1, for example 2, we'll get a number that is bigger than the initial number. So, how does this help us? For values of fx that is between 0 and 1, what this means is that fx squared will be smaller and hence below fx. So it will look something like this. For fx equals to 1, fx squared would still be 1. So you get that the graphs of fx and fx squared actually intersect when y equals to 1. And for fx that is more than 1, fx squared will be greater than fx. Let me draw this a bit properly. The graph will look something like this. And note, earlier, remember for the modulus graph, the points over here will be sharp points. But when we are squaring, these points over here actually become a smooth curve. Here's the summary sheet for all the additional transformations. Thank you so much for watching. I hope this greatly benefited you.